Hello, my name is Cecilia Rivas, and I am a sophomore student at Trinity Washington University. This past summer, I worked with Dr. Casiano-Negroni and Ms. Nicholls on a project titled Screening of Phenolophthalein and Weight Loss Supplements using reverse phase high-performance liquid chromatography. Our goals were to develop a method to detect and quantify phenolophthalein using HPLC and screen randomly selected weight loss supplements sold in the Washington metropolitan area. We hypothesized that we would be able to detect phenolophthalein in some of the weight loss supplements, since it is a laxative that could be a hidden ingredient used to help with the effectiveness of the product. In the United States, weight loss supplements are regulated by the Food and Drug Administration as foods and not as medications. Tests conducted by the FDA and other groups have found many dangerous chemicals hidden in these supplements. This is dangerous because about 15% of the adult population in the United States has claimed to use weight loss supplements at least once in their lives. One of the dangerous chemicals the FDA found was phenolophthalein, which is known for its laxative properties and as a pH indicator. Due to the potential carcinogenic and genotoxic risk, it has been banned in many countries. Due to the lax regulation laws, the threat posed by adulterants, and the ever-present diet culture, it is important to continue screening weight loss supplements for such chemicals. Our first step was to analyze a list published by the FDA that contained adulterants found in weight loss supplements from 2009 to 2022. We wanted to learn more about the different types of hidden chemicals used and if it was common to find phenolophthalein among the list of adulterants found. Our findings in Figure 3A show that 55% of the tested supplements contain sibutramine, which is an anti-obesity drug, and about 14% of the supplements contained phenolophthalein. In Figure 3B, we can see the reoccurrence of the adulterants per year, starting in 2016 to 2022. We noticed that the adulterants have decreased over the years. For example, sibutramine was found 19 times in 2016 and about only 2 times in 2022. We then started screening supplements. We tested 6 weight loss pills. One of those supplements was from the FDA list we analyzed. We also tested 6 weight loss teas. All the samples were analyzed using reverse phase HPLC methodology that we developed. Because we were using a UV detector in our HPLC instrument, we determined, as seen in Figure 4, that the wavelength of maximum absorbance that we needed to use was 230 nanometers. In Figure 6, you can see the HPLC chromatogram for all our samples. The first chromatogram is of a phenolophthalein standard concentration of 1.2 millimolar. It is showing that the phenolophthalein peak has a retention time of 3.5 minutes, meaning that if phenolophthalein is detected in a weight loss sample, a peak will show up at this time. All of these samples did not show a phenolophthalein peak. An example is the chromatogram in Figure 6B. After overlaying the chromatogram of a spike sample, it clearly shows that phenolophthalein was not detected. We only detected phenolophthalein in 5 of the 6 weight loss pills that were studied. Figures 6C, D, and F show samples where this adulterant was detected. We then wanted to quantify the number of adulterants found in these 5 weight loss pills. For this, we first created a calibration curve. Here we measured the area of the peak at different concentrations of phenolophthalein as shown in Figure 5. This was used to find the concentration of phenolophthalein. Table 1 displays a summary of our preliminary findings. The concentration of phenolophthalein in the samples ranged from 0.000778 millimolar to 2.52 millimolar. Glutabio was found on the FDA list of supplements with adulterants, and it has the highest concentration. In conclusion, we were able to develop a methodology to screen weight loss supplements using HPLC. Our preliminary results show that some of the weight loss supplements were adulterated with phenolophthalein. In our future research, we plan on improving our methodology and quantification methods. Ultimately, we plan on adopting this project as an independent laboratory activity for chemistry students. I would like to thank NASA DC Space Consortium for funding. I would also like to thank my mentors, Dr. Casiano-Negroni and Ms. Nicholls, for their ongoing help and encouragement with this research. Thank you.